Hi, this is Dale Rhoda with Biostat Global Consulting. Welcome back. This is the second video in the series on how to make inchworm plots, where we have provided data programs for you to download and Excel programs with demo information in them for 3 different plots so that you can try it out yourself. You can change some of the options and get a feel for how to control the different aspects of an inchworm plot. Inchworm plots have a lot of options, a lot of things going on. Here's the first plot that we're going to make. This is for the fictional country of Harmonia. We're looking at Penta 3 coverage. And the data that controls this plot are all contained in an Excel file that you are able to download. Let's zoom in here. This Excel file has several tabs. The tabs have to be named what they're named here. So if you want to make your own inchworm plot, I recommend starting with this file, cleaning out the contents, and then filling it back in. Both the tabs and the variable names are fixed and important, and they need to be just what you're seeing here in this file. For this plot, the source of our data, we're not analyzing a survey data set. We're maybe creating a plot from an old summary table or something. So we know the effective sample size and the estimated coverage. So the source of data we specify as ESS. The other option here would be the word data set if the estimates would come from the data set. In this case, we're specifying the coverage and the effective sample size. So for each shape in the figure, we've got one row in this data set, and we indicate the following information about each shape. What row should it appear in the plot? Row 1 is the bottom row, and then we count up from there. What will be the row name? So you can see here the lowest row is Charleroi, and then Taramba. Here we go. You can see the one-to-one correspondence between the Excel file and the figure. Parameter 1 is the effective sample size. You can read about that when you type in Stata help IWplot survey P. We'll show you that in a minute. Parameter 2 is the estimated coverage. Parameter 3 tells us what kind of confidence intervals we want. Parameters 4 through 7 are not used if the source is effective sample size. They are used if the source is dataset. And here are some additional parameters. For each shape, we specify the outline color. We specify the fill color. And for the fill color, how intense should it be? In this case, the intensity is going to be set at about 75%. So the area color, or the fill, will be a little less intense than the outline. And finally, we specify for each shape whether the base should be clipped at the 95% confidence interval. If we specify 95 here, then the base will be clipped. Should we show tick marks for the lower confidence bound and the upper confidence bound? And if so, what color should those tick marks be? And finally, for one shape, we're shading behind the row with grayscale 14. And you can see that here in the shape for Harmonia. We've shaded this entire row. It's meant to draw the viewer's attention to this row and show that it's an aggregation of the data from all the other strata. And so that's the information about each distribution. There are other tabs that give information about the horizontal lines. We have 2 horizontal lines in this figure on either side of this gray band, and we have 2 vertical lines, a red one and a black one, in this figure, and those are described by the tab named vertical lines. Where should those lines start? Where should they stop? What color should they be? Etc. So in order to make this figure, we type the command Excel wrapper for IWplot survey P. This is one of the commands we've provided for you. And then we tell it the name of the spreadsheet file. And the program, in just a few seconds, it will read the spreadsheet. It turns each of those tabs into a Stata data set, calls the inchworm plot program, and makes this figure. So that's the Harmonia example. There are also 2 Nigeria examples, and they differ from Harmonia really in one important respect. The most important respect is that the data for this plot comes not from figures we already have. We don't know the coverage for this plot. We're asking the program to estimate it from a data set. So in this case, we're looking at the Nigeria example number 1. When we look at the distribution info tab, we see here that for these shapes, the data is not coming from an effective sample size that's already known. We haven't filled in parameter 1 and parameter 2 here. Instead, the estimates will come from a data set. So row number, row name, those are the same, but now we've filled in parameters 4. Parameter 3 is the same, Wilson. Parameter 4 tells us the path to the data set that contains the data set. Parameter 5 is what variable do we want to summarize. In this case, it's got crude measles-containing vaccine to analyze. Parameter 6 is the status survey set syntax. And parameter 7 says, for this shape, for the shape described in this row, which observations shall we summarize? We can see here that for the first row, we don't specify any if syntax, so this is going to summarize all of the respondents in the dataset. And for each of the subsequent distributions in the shape, in the figure, each of these 13 shapes is a subset of the data. And so we're using the if syntax here to say which respondents should be summarized. In row 2, it's the respondents who live in the Northeast zone. Level 2 name equals Northeast. In row 3, it's the respondents that live in the state of Adamawa, and then Bauchi, and then Borno, etc. When we get up to this row, now we're looking at the Southeast zone, and then each of the states in the Southeast zone. In this case, we've plotted them in alphabetical order, starting at the bottom. It's a strange choice. We could rearrange the order of the rows in this data set, or we could change the values for a row number here, and that would reorder the shapes in this figure. I would probably recommend doing that. If we're going to go with alphabetical order, maybe it should be alphabetical reading downward instead of upward. And as you know, by this point, I generally like to order these plots so that the coverage increases from bottom to top. So I might show this state at the bottom of Southeast, and I might show Borno at the top of Northeast. That's Nigeria example 01. You can run it with the files that you've downloaded. You type this command, Excel wrapper for IW plot survey P, Nigeria example 01, and in just a few seconds, Stata will read that spreadsheet, call the appropriate Stata commands. It will make the coverage calculations from the data set and plot the appropriate inchworm plots. And then it will save the figure because you've told it under command lines that you want to export the figure to a PNG file. The last distinction we'll make in the second Nigeria example, everything on the distribution info page is the same, but we've added a text box because we know in this data set that some of the clusters in the state of Borno were inaccessible. And the coverage appears to be quite high, but we want the reader to know some of the clusters were inaccessible, so the coverage might be biased there. So we're adding a text box on the plot, and we're adding an arrow on the plot. And you see that here. Here's the text, and here's the arrow. We specify the location for the text, the location for the arrow. We do that in the tabs named arrows and text box. And the other thing that we've changed on the command line, we've changed the aspect ratio of the plot. So now it's 20 units wide and 14 units tall. These are Stata X size and Y size commands. These numbers can be anything from between 0 and 20. So we've gone from the tall figure, which we had with example 1. Now we're showing the same figure, but we're showing it wide. We've added the text box and the arrow. Download these examples, give them a try, and then give us your feedback. Send us your feedback and your questions. If you have comments, put them in the Survey Scholar update where you found the link to this video, or send us an email. Thanks very much.